coding challenge, and today we are going to solve pass sum third. So let's start. Given the root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downward, traveling only from parent node to child node. We have given a binary tree and the target sum. We need to count the number of paths where the sum of node is equal to target sum. So one valid path is 5 and 3. The sum is equal to 8. 5 to 1 is also a valid path, and minus 3 and 11 is also a valid path. 10 minus 3, 11 not a valid path. 10, 5, 2 is not a valid path. You can try other path also. But for this, the output is 3 valid path. Now let's discuss the answer. We are creating a hash map which will store the frequency of the prefix sum. Our target is 8. And we are initializing a hash map which is stored the frequency of the prefix sum. And to find the answer, we are going to use this logic. We will keep on calculating the current sum for the path, and we will deduct the target sum from it, and we will check in our map what is the frequency of current sum minus target sum value, and we will keep on adding to it to our answer. So let's do the try run and try to solve this binary tree. So first, our hash map, I have our initial prefix sum is 0 because there is no node, and initial prefix sum is 0. So the frequency of prefix sum is equal to 1, correct? Now, when we go to the root node, now our current sum goes to 10. So we update the value in the map. So 0 is equal to 1 and 10, and the prefix, the value of the prefix sum 10 is equal to 1. Then we do the DFS traversal to the left node. Now we reach to the 5, the current sum goes to 15. And we check current sum minus target sum if there is any value. So current sum is 15. 15 minus 8 is equal to 7, and there is no value in the map with the value 7. So we only add 0 to the answer. So now we update the prefix sum 15 to our map. Then we go to our next node. 15 plus 3 goes to 18. We check 18 minus 8 target sum. 18 minus 8 is equal to 10. If there is any value of, if there is any key of 10 in our map, there is, and we add it to the answer. The frequency of 10 is equal to 1, and we add it simply to our answer. So at this point, our answer goes to 1. Let me write it. So here our answer goes to 1. Now we go to the next node. We do the current sum 18. 18 plus 3, 21. We check 21 minus 8 goes to 13, and there is no key with value of 13. So there is no path exists for this node where the sum is equal to target. Similarly, 18 minus 2 is equal to 16. 16 minus target 8 is equal to 8, and there is no key exists with the value of 8. Now we go to this path, and now our map is this. When you go to this path, 15 plus 2 is 17. 17 minus 8 is equal to 9. There is no key in the map with the value of 9. So we update the value of 17. So 17 is equal to 1. Our prefix sum is updated. Next we go to the next node. 17 plus 1 is 18. 18 minus 8 target sum is equal to 10, and there is a key with the value of 10. So again we update our answer. So here also the answer goes to 2. We add one frequency of 10 again, and there is a one valid path now. Now we go to our right side of binary tree. 10 minus 3, the current sum goes to 7. We do current sum minus target sum. There 7 minus 8 minus 1. There is no key with the minus 1. So we update our hash map prefix sum. 7 is equal to 1. Now we again do the current sum. 7 plus 11 is equal to 18, and 18 minus 8, our target sum, is equal to 10. And there is a key exists with the value of 10. So again we got one path. So we update our answer value. So answer goes to 3. I hope you understand the logic. Now let's do the coding part to solve this problem statement. So first we are defining a prefix map, hash map of type integer comma integer that call it prefix sum, and we are also define an range to count the valid path. Define your DFS logic. There is a tree node, and there is a current sum always. Let's say K is our target sums. In DFS, if our root goes to null, we simply return it. Now do the DFS traversing. Root dot left comma sum and DFS root comma right comma sum. This is the DFS traversal logic. We need to update our sum every time. So sum is equal to, this is our current sum value. Let me call it current sum. Now we apply this logic, map.get current sum minus target sum. So to our count, from the prefix sum, we get the value of current sum minus our target sum. So K is our target sum. I'm initializing it here. K is equal to target sum. Comma 0. If there no value exists with the current sum minus K, we simply return 0. Again, we also need to update the frequency also for the current sum. So prefix sum dot put our current sum value. We need to find the previous value and add 1 to it. So prefix sum get or default. So we are basically adding the frequency of the prefix sum. So if there is any value or already exists, get that, or else get the default value of 0 and add 1 to it. So we have increased the frequency of prefix sum. At last, after we have done with the processing, we also need to remove the key. So when for the root node, we are going to the left, and after we are returning from the left, we also need to remove all the key that we have added on the left side. So remove the prefix sum at the end. So prefix remove the current sum and the add. So current sum. So here we are incrementing the frequency, and here we will decrement the frequency. Prefix sum output get or default. I simply can do like this, and we have decreased the frequency. Do it to add the default logic. And if our current sum frequency goes to 0, we can remove the key itself. With dot remove the key itself. And we have done with the logic. Now we can initialize our prefix sum every time. Prefix sum equal to new hash map of type integer comma integer. K is equal to target sum. And count we can initialize 0 every time and call our DFS. Also, we need to pass the initial sum of 0 to it. Pass it. Prefix sum dot put 0 comma 0 comma 1. And one more thing, our sum may can get greater than integer. So we might need to use long instead of integer. So long, and our sum we can make long. If is not required. And yeah, and we are done. And now call our DFS method, passing the root node and our current sum value. So current sum value is 0. So coding part is done. Now let's try to run the test case. I need to pass the current sum. Yeah, we also need to return our final answer, that is found. So our test case is working. Now let's submit the solution. Our solution is also working. And thanks for joining the session. Let's meet tomorrow.